Welcome to another video from Unrated Hardware. My name is Monero, and today I'm going to give you guys an update of what I've been doing recently. So what I have here is a prototype kit I've been building that is to operate a LoRa Gateway station. So what is LoRa? Well, basically what it is it's a low power communication system. Very long range. It doesn't require a license to operate. And basically what I'm going to be using it for, a family member has requested I built them a moisture sensor system for their farm fields. And so I have a sensor right here. This particular one is about a foot deep, has a probe here, and in the top there's a transmitter. And then this would go receive it and send it to the cloud, and everything in the cloud could be sent to your program where you can go and monitor your fields. Okay, so stations are expensive, and so that's really the reason I've been trying to make my own. That I've seen some that are quite literally $800 or more. A lot of those ones, there's been a lot of new ones recently, and they've been satellite operated, that were when the company you buy them from has it connect to some satellites and just uses just internet satellites to relay the data. It isn't very much, and so kind of the price that's included. I've chosen with this approach. When I started this project, there were not very many LoRa base stations available, so for my connectivity, since it's going to be out in a farm field and receiving stuff from miles away, I have a Verizon jetpack. So basically this will be talking to the jetpack, and then this will go up into the cloud. So it's a relatively cheap way. I think it's about $10 a month for one of these jetpacks to add to your plan. That would allow you to get you internet access. So what I have here is, for my test bed I've been working on for a while, there's a Raspberry Pi 3. Apparently Raspberry Pi 4 has had problems with more problems than Raspberry Pi 3 has. It's kind of weird. So I have a Pi 3 in the bottom, and on top of that, if I go and pull this off here, I have a UPS unit. This is a SupTronics, I think. It's a SupTronics X700. Basically, it's a UPS unit for Raspberry Pis. It has both a micro USB input and a DC barrel jack, as seen over here. So basically, this takes 18650s. You can either have one or two on here. I've decided to really put two, just because this radio over here uses a quite ton of power. The Pi itself hardly uses any. So I put two on. I salvaged them from laptop battery packs. I'll probably buy some cells later that are longer longevity and aren't used already. So these are just some donor cells I have. And what I found with some of the stuff I've been doing, the 5-volt in is not adequate. SupTronics, this is an okay UPS hat. It's not. I've seen some flaws with it. One being that the power regulation in it is not optimal. It's not very smart when it comes to taking incoming power. I had a name brand Canakit Raspberry Pi charger. I plugged into here. You're not supposed to plug in there when you're using this. And basically it's a 2.5 amp 5-volt, very name brand. And basically when I went and discharged these batteries some, after just testing them out and seeing how the UPS ran, I discharged them for about 3.5-4 hours, and they were down to 50% with the Pi at pretty much idle. And I went to go plug it in, and then the Pi started complaining. It started giving all these low voltage stuff, and I was really freaking out, what's wrong with this? And then I figured that it is not smart enough to relay adequate power to the Pi. So anytime, even with the Pi at idle, if these things need to be charged, it will put all the power towards these. So it's not very smart. I know it's kind of a bad design. So the way I've worked around with it is 5-volt DC barrel jack. I have one around from a Boudroid XU4. It's a 5-volt 4-amp jack. I plug that in. It's a real big brick, but I had it around and there were no problems after that. It was able to simultaneously charge these batteries and keep the Pi happy. Especially with this radio on there, radio board in there. I don't want to risk undervolting or having some undervoltage and have it complain and even cut out the video at times. It was acting real weird. So if you're going to do anything with any Pi UPS or if with this X700, please provide adequate power to it. It is fully functional right now, pretty much. I pulled off the hat. This is from Sandbox Electronics. This is probably the most expensive part of this project. For $150, you get okay, let me think here. An IC880A. That's the chipset in here. And you can also get a GPS unit. This is useful for calculating times and stuff with LoRa and sending stuff. So it's not required. I haven't got it working yet. For whatever reason, software. So, and then here's the antenna right here. It's not very big at large antenna, but it definitely does the job. At least from what I've tried around here, it's done pretty good. I need to do some range tests later. So here's underneath the hat. If I can, there's not much under there, and so far, at least I've been able to get these both two to work together as hats without any problems. They do not use the same interfaces. This one uses UART for all its communications, and this one uses SPI. So with what I've found with SPI and stuff, with the Raspberry Pi 3 or the Raspberry Pi 0W, there's an SPI bug where the onboard Bluetooth is taking the default SPI interface. And so a lot of programs, when they want to go use SPI, they will not use the secondary SPI interface. And so basically the easiest way to do that is to disable the Bluetooth, and that's what I've done. I do not need it. And I turned that off and I was able to communicate with this. So the GPS, I believe, from what I've seen, uses a serial connection. So between these two hats, it uses about all the pins. So I thought about, for the enclosure I was putting on, having the wires go off and spread it out a little bit, because this gets really tall when you stack everything up. But then I realized that I'm using most of these pins between these two hats. And that's all I pretty much have for this. Since I'm using Wi-Fi because I found USB connections with the jetpack are kind of interesting. It works about half the time, but since it has Wi-Fi on there, and I'll be able to get more creative with placing this in the same enclosure, I'll just use Wi-Fi. Because at the site, if I need to adjust anything, I can just connect to the Wi-Fi network it has hosted. There's nothing out there, so I don't need to worry about anybody else connecting. It's password protected. The SSID is hidden. It's short range. So it's turning on now. It should be booted up, and my jetpack says it's been connected. So now I have the server going. I need to go fix the auto start. This is kind of what it looks like. Took me a while to go find, to get to the view of it, to actually really see, hey, is that actually running? I haven't registered the gateway yet. So it is going, it's talking, and you can see a lot of stuff about RF packets. So I'm going to activate the sensor. In this case, these sensors, you actually flip them right side up instead of side down. And then in probably a minute or so, you'll see in one of these threads, there'll be RF packets received by concentrator, and that's basically acknowledging it's received something. So it's still going. It only updates how often it receives packets every minute, a couple minutes. so it'll take a little bit to cycle through. And here's how I shut it down safely. I just press down on this. And it's my SSH connection is dropped, as you heard from the background from my computer over there. And this flashed and it went and shut down, and the light shut off, and the power is now cut to the whole board. Okay, this is the enclosure I decided to use. There's a website where you can go get a bunch of enclosures. I forgot what it was, but I might link it later. So it's a solid like plastic box, and it has nice threads. There's a lid, and there's also a weather seal back there for it. What I'm planning to do is use this box, the enclosure, over here. I'll bring it into view. This thing is awfully big right now, so once I get a Pi 0 on there, it should be shorter, and then even then it'll be a little bit tight, and I might try to set it everything over down in this area and put the MiFi jetpack up over here somewhere. And then I'm going to cut holes in the side and have a little electrical box. Probably the hardest part of this whole thing is keeping that radio board cool. Like, I mean, it doesn't create a ton of heat. There is no way to dissipate it. There is no heat sink on this unit over here. So basically what I've done, this is a heat sink from a North Bridge on an old AMD motherboard. I pulled it off. I'm going to sand down this bottom. Then I'm going to find some sheet metal, and probably some thick, maybe 1/8 of inch sheet metal. And after this is sand down, I'll cut the sheet metal and make a heat transfer plate. And then I have this fan. These for I think this is it like a 20mm fan? It's real small. Yeah, it doesn't say what it is. It only uses about 1/5 of an amp, so it's hardly anything. You can get these for Raspberry Pis, and that's what I ordered for this. But if it's an enclosed box out in a farm field, the box is going to need additional cooling. So what I've done here, this is a 5-volt a laptop fan from I think a HP laptop. Conveniently, I think I might be able to wire up to a fan controller. Yeah, I could probably find it for a couple dollars. I'll have to figure that out later. And I might be able to set it to a temperature controlled cooling. So I'm going to have to find a way to make this weatherproof and to have it keep the Pi cool, because this is going to be in a relatively enclosed hot environment. I do not want it to cook itself. And vice versa, when it gets super cold, I want to be pushing a bunch of cold air and literally freezing the 18650s. That would be bad. It'd kill the cells, and then this whole thing would shut down if there was a power outage, and yeah, it'd be a bad thing. So I'll have to come and find a way to get a PWM controller for this. I'm pretty sure that UPS hat has several 5-volt outputs. I can probably try and see if I can run it full speed. Probably I'm not. So I want a controller so I can turn it on and off. But that's what I figured out. And it's really a big work in progress. And part of the reason for me doing this video is I can kind of see what I've done and show other people. I've had some people, some of my friends and some people I talked to are really interested in some of these LoRa stuff. LoRa is a very upcoming technology. There's so much development in it. It's crazy. I can't even keep up with it.